All right, so today we're going to be looking at section 4.2. We're looking at isosceles and equilateral triangles, so I'm going to give you some information about these. And so isosceles triangles, what you're looking for in this one right here, two sides of a triangle are congruent if and only if the opposite angles of those sides are congruent. So this is the definition basically of an isosceles triangle. It has two sides are congruent, and these two base angles are congruent. So if I tell you that two sides of a triangle are congruent, then I have also told you that the base angles are congruent. And if I told you the base angles are congruent, then I've told you these sides are congruent. This angle right here, the third angle, is called the vertex angle. Okay, and so that's isosceles triangles. An equilateral triangle is also considered isosceles. Well, everything that happens to an isosceles also happens to equilateral, just more so. Equilateral means all three sides are congruent, which means all three angles are congruent. And by deducing the fact that they're all the same angle and they all have to add up to 180, we know that each angle in an equilateral triangle is also 60 degrees. So we know this to be true. Okay? So here's some things we want to keep in mind and how that helps us out. If a line or line segment bisects the vertex angle of an isosceles triangle or any angle of an equilateral triangle, then it also is the perpendicular bisector of the opposite side. So what this is saying is this. If I bisect this vertex angle, so those two angles now are congruent, and it's isosceles because there's the isosceles marks, then not only does that bisect that, it also bisects the opposite side, and it will be a perpendicular to the opposite side. So it becomes a perpendicular bisector. And vice versa. So if this is a perpendicular bisector, then you can deduce that this is going to be, well, I should say that. So this is what we have. Okay? When I do an equilateral triangle, the same thing works for all three angles. Okay? For an isosceles, it only works when I bisect the vertex angle. So we're going to use this information of these different types of triangles here to answer some questions and go through some problem types. So let's look at some of those, and I'll show you how to deal with those problems. So here we go. First example, what is the value of x? So assuming you can see it, let me zoom in just a bit. These may be a little harder to read. But what I have here is I can see from this picture right here that I have these marks indicating that this is going to be an isosceles triangle. If it is an isosceles triangle, then I know that the base angles are going to be congruent. So if this one here is 28, then I already know that this one then will be 28 degrees because it has to be isosceles. So what is the value of x? Well, three angles add up to 180. So I can just simply put 28 plus 28 plus this angle, which is maybe hard to read, but it says 5x plus 9 has to equal 180 degrees. And so that is how I get my equation. I can then work this out, combine like terms, and solve this for x. And so 5x is 115, and so x is going to equal 23. And so that's how you can do that problem. In this scenario over here, again, I have these marks indicating that this is going to be an isosceles triangle, which means if that's the case, the base angles must be equal. And so that's how I get my equation from this one. Plus 9 must equal 8x minus 3. And then I can solve this one. Okay? I can add to 4x, add to 4x, add to 3, add to 3, and I get 12 equals 12x, and so x equals 1. Okay? Here's a picture. These marks indicate that this is going to be an isosceles triangle, which means these sides must be congruent, and so I can use that knowledge to answer this question right here. So what is the value of x? Well, 8x minus 1 is 4x plus 5. we can solve this for x. Moving things around, I'll get 4x equals 6. So x is 6 over 4, which reduces to 3 halves. Always reduce your fractions. What are the lengths of all the sides of this triangle? Well, here's the equations or expressions to evaluate each side length. So we just got to plug in the 3 over 2 into each of those and find their value. 8 times 3 over 2 minus 1. And then we have 4 times 3 over 2 plus 5. And 2 times 3 over 2 plus 11. Now, these two sides must be equal in length. So if we work this out and they're not equal, then we have an issue. But for our sake, we already know that they're going to be. Okay? And so there would be the answers for all the lengths. In this example right here, what have I shown you? These marks indicate that this is an equilateral triangle. This line right here and these marks right here indicate that these two angles are congruent, which means that line is an angle bisector. And if it's an angle bisector in an equilateral triangle, okay, this, by the way, is 31. Because it's isosceles, I know this one is 31. And this angle, this line right here becomes a perpendicular bisector of the side. So not only is it touches here, it touches at a 90-degree angle, so I know that already. So what is the measurement of RSQ? So let's trace it. RSQ. What is the measurement of that angle? Well, to find this, okay, what we want to do is we want to go through and figure out a bunch of things. So I know because this is isosceles, like I said, that was 31. The three angles of the triangle add up to 180, and so that's where I need to go. So 31 degrees plus 31 degrees plus the measure of angle RSP is 180 degrees. So working this all out, the measurement of angle RSP, so this whole angle here, is going to equal 118 degrees. Well, our angle, the measurement of angle RSQ, is 1/2 because it bisects that angle, RSP, which means our angle is 59 degrees. And so this is how you can display your work and write your answer out. What is the length of PR? PR is the whole side down here. Because I know this is an isosceles triangle and this was the bisects the vertex angle, it bisects this opposite side. So I know that side is a 4 also. So PR is simply 8. Okay? All right. Find all these things here. So find the measure of PNO. So trace it out. PNO. So that's this angle right here. Trying to find that. So what do I know? Well, I know that triangle MNP is equilateral. So angle MNP is 60 degrees. That angle is 60 degrees. In fact, all of them are 60 degrees. So I can tell clearly then that this angle, the one I'm looking for, the measurement of angle PNO plus 60 degrees is 180 because they are a linear pair. And so the measurement of my angle that I'm looking for is 120 degrees. Okay? The next one is find NOP. NOP. And because these things are, this triangle is isosceles. Okay? So I know because triangle PNO is isosceles, I know that these two angles are congruent. Angle NOP is going to be congruent to angle NPO. So I know that to be true. Okay? And so then I can use that knowledge to work all this stuff out. I know this angle is 120. These two are the same angle, so I just need to do 2 times the one I'm looking for. So 180 degrees is 120 plus 2 of these because they are identical. These two are identical. And so I can work this out and I can get my angle NOP to equal 30 degrees. Okay, so move the 120 over here, makes that 60. Divided by 2 makes it 30. And so that's how I can get to that. Okay, and so that is what we did in 4.2. And we'll do more together in class.